Technology could look like solar panels, or a bioreactor like a brewery.
Fascinating stuff. Let's get some more insights and bring in Tommy Bakey. You just saw him there in the report. Mr. Bakey, thank you so much for coming into the show. This is a remarkable discovery. How did you come up with the idea?
Well, we were actually sitting in a bar where we came up with this idea. It was a real experiment. We actually didn't know what would happen. And we had a real privilege to really be there and go like, wow, we've actually managed to see these charges form in photosynthesis, and then eventually worked out how to intercept them.
You've come about what everyone seems to be desperately looking for right now, a powerful source of quite literally green energy. What could your technology mean for the development of the renewables sector?
Well, it's quite interesting because we already rely on photosynthesis for everything we eat and for everything that we breathe, as your really good piece outlined. But what we think now is that we might be able to rely on the plant world also to power some of our devices.
Now, how clean is the resulting energy really? How about the process's own carbon emissions, for example?
Well, photosynthesis actually grabs carbon from the atmosphere. So it's a very difficult technical question to answer actually how green a specific technology is. You have to take into account how you're making it, where you have to transport it, and how you might recycle it in the end. But usefully, using plant-based solar cells, really all you need to do to make it is give it light and water. And it has this additional advantage that it actually takes carbon from the atmosphere, which is something that traditional solar panels wouldn't be able to do.
It almost sounds too good to be true. What needs to be done to use it on a bigger scale in the future?
Well, we've already outlined how, for example, we can use this technology to power computers for relatively short periods of time, admittedly. But when we push something out to the real world, we have to consider what's called the levelized cost of electricity. So the amount it costs to make it and install it, and the efficiency that you get out, the power that you get out. That comes into what's called the levelized cost of energy. Now, we can't claim that we're ever going to be as efficient as a silicon photovoltaic. But what we can claim is that it could lead to incredibly cheap solar panels because you can just add, as I said before, add light and water and you get quite a good solar cell. So hopefully being able to use the abundance of water and light that we have on this planet